Last week we talked about powers, but let's recall. Multiplication is a shortcut for addition. 4 times 5 means that you take the number 5 and you add it to itself 4 times. By the way, my multiplication sign is a dot. I don't usually use a cross for multiplication. In the similar way, 4 to power 5 means that we take number 5 and we multiply it with itself 4 times. Let's see some more examples. 3 to power 4 would be 3 times 3 times 3 times 3. Well, how to calculate this? This 9 and this 9, so 9 times 9 will give 81. 4 to power 3 on the other hand would be 4 times 4 times 4. Well, 4 times 4 is 16, and 4 times 16, maybe I calculate in this way. It is 4 times 10 plus 4 times 6. I will get 40 and I will get 24, and together these make 64. We see that 3 to power 4 is different than 4 to power 3. We want the powers to work in a logical way. So, for example, 3b to power 3 would be b times b times b. b to power 2 would be just b times b. And b to power 1 is b. So it seems that we take one b out here. Well, by using this logic, what would be b to power 0? We wouldn't have any factor b there, but we can imagine that in all of these products there is a factor 1. If we take this b out from here, we will just get 1. Next, the thing that we take 1b out, we can see that it is the same thing that we divide by b. So, if we would continue to make the power smaller, we would take this number 1 here and divide it by b, and we would get 1 over b. Like this. From here we get a calculation rule for powers. Some number a to power some number b to power n is the same thing as this one, or b to power minus n is the same as this. Well, some numerical examples, so let's see. If we think about the rule that any number to power 0 is 1, for example 16 to power 0 is 1, and also 100 to power 0 is 1. For the rule that number to power minus something makes the reciprocal, maybe we think about 3 to power minus 1. Well, that's 1 over 3. How about 3 to power minus 4? That would be 1 divided by 3 to power 4. We just calculate 3 to power 4 is 81. Next, some calculation rules where we have a product and it is put to some power. How can we simplify this? Well, the rule will be that we put the power to both of the numbers. How can we check this thing? Well, let's see. If we would have 2 times 3 and it would be to power, let's say, 3. Let's put 2 times 5 to power 3, so it is like we have unique numbers here. Okay, so we would take the thing 2 times 5 and we would multiply it together with itself 3 times. And now, because multiplication is associative calculation, we can take all the parentheses out, and we can also change the order in the multiplication. We can group the numbers 2 here together and numbers 5 here together. We will get that this 2 to power 3 times 5 to power 3. Considering this calculation, we come to the conclusion that this formula must be true. Of course, we can use the formula to any direction. We can go from left side to right hand side or from right hand side to left hand side. So for example, if we have 1/2 to power 3 times 2 to power 3, we can take the power 3 as common. So let's take power 3 as common power and let's put the numbers here. Well, now luckily we get here 1, so we just get 1. Maybe a couple of more numerical examples. 3 times 4 to power 2 is something like this. How to calculate 9 times 16? Well, 9 times 10 plus 9 times 6, this would give 90 and this would give 54. Together these are 144. Well, on the other hand, if we would make the product 3 times 4 would be 12. And what is the square of 12? We could calculate somewhere. 12 times 12, how much is that? If we multiply with 2, we would get 24. If we multiply with 1, we would get 12. And summing up these numbers, we would get 144. So, also in this example, we get the same result. The formula seems valid. So, we had the formula that a times b to power n is the same as a to power n times b to power n. In the same fashion, if we have a divided by b, and that is to power n, we need to put the power n to both the numerator and the denominator. So, for example, if we would have 3 divided by 4 to power 2, it comes 3 to power 2 divided by 4 to power 2, 9 divided by 16 is the result. In these formulas we had two numbers a and b, and they were put into a power. On the other hand, if we would have a number a to power n times a to power m, what would this be? Well, for example, 2 to power 2 times 2 to power 3 would be, we can express the powers by using multiplication. Here is 2 to power 2 and this is 2 to power 3. And now we can see that there are in total 5 of these factors here. So we get 2 to power 5. That is 2 to power 2 plus 3. So thinking in this way, this formula must be equal to a to power n plus m. Well, let's see a couple of more examples about this. If we would have this kind of product, we can change the order of the product and we can just okay, no need to do that even. In total there are 3 of the factors x, so we get x to power 3 and 5 of the factors y, so we get y to power 5. Here 2 plus 3 is 5. What else? 2 to power 1000 times 2 to power minus 999. We can combine the powers. It's 2 to power 1000 minus 999. We get just 2. In this formula, we can also make an analogy for the fraction. So if we would have a to power n divided by a to power m, we will have a to the power where we take the difference. A numerical example about this: 3 to power 50 divided by 3 to power 48. We can put both of the powers here. The result is 9. By using this formula, we are able to simplify fractions. So let's take, for example, this fraction. We can see the variable a both in the numerator and denominator, and in total the power for a would be 2 minus 1, and in total the power for b would be 3 minus 2. So we would get a times b. Well, this is one way to do the calculation. Another way, if we don't, for example, remember the formula, is just to use the definition of powers. So we can express a to power 2 as a times a, and b to power 3 as b times b times b. Expressing all the terms in this way, we can cancel out some of the terms. In the denominator, we can now imagine that there's a factor 1 here. So in the end we will get the same result. Here are the formulas what we were using here. There might be more of these formulas. The main thing is that you can use the definition of powers to check that these formulas are true.